Fondazione Bruno Kessler, founded in Trentino, a province in northern Italy, consists of more than 350 researchers and conducts studies in the areas of information technology, materials and microsystems, Italo-Germanic studies, and religious sciences. The MIT Mobile Experience Lab focuses on creative and radical research to reinvent the modes of connecting people, information, and physical places using cutting-edge information and communication technologies. The Mobile Experience Lab, founded and directed by Professor Federico Casalegno, is part of the Comparative Media Studies of the School of Humanities, Arts, and Social Sciences at the Massachusetts Institute of Technology. Residential buildings are responsible for almost half of the global yearly building energy consumption. Thus, improving energy efficiency of houses is critical in addressing the global energy challenge. In collaboration with the Fondazione Bruno Kessler, the Connected Sustainable Home is the brainchild of the MIT Mobile Experience Laboratory and aims to bring the home of the future to fruition. In the past 4 years, we systematically examined key architectural elements of houses, such as the wall, floor, window, and ceiling. The Connected Sustainable Home prototype can achieve drastic gains in energy efficiency by parallel deployment of 4 technologies: passive high thermal mass materials, electroactive materials, clean energy production systems, and a model-based control system integrated with the intelligence necessary to implement a wide range of long-term energy optimization strategies. We seek through this project to pioneer new methods in building that are in harmony with the environment and employs the latest technological innovations. William J. Mitchell, born 1944 to 2010, pioneered cross-disciplinary research and design and set the general vision of connected sustainability. His ideas included combining physical with computing architecture to improve energy management, and in the spirit of early farm communities, proposed sustainability through collaboration on a community and urban level. The spatial arrangement of the house is organized in modules that can be combined in alternative ways. The current version of the prototype is the minimal configuration of 3 spatial modules accommodating basic house utilities such as living, sleeping, and eating. These were produced in collaboration with IVALSA, the Trees and Timber Institute of National Research Council of Italy. They are prefabricated in the workshop and then transported to the site for assembly. The modules were designed to satisfy the requirements of transportability. This includes the safe lifting and easy maneuverability of components and dimensions necessary to fit into a standard shipping container. This overall module and transportable building system, designed by MEL and IVALSA, demonstrates a way to use wood, a natural material, to build contemporary, prefabricated high-tech structures in a manner more economical, light, and environmental friendly than conventional construction. The dynamic facade covering the south elevation of the prototype is a programmable surface that adapts to changing weather conditions and personal preferences. It's a matrix of 3x9 digitally controlled windows able to regulate air, daylight, and heat flow. Each window pane is an overlay of 2 electronically switchable materials, a polymer dispersed liquid crystal film that can render a window transparent or opaque to visible light, secure in privacy, and a sage electrochromic layer controlling the degree of solar penetration, securing thermal performance and light illuminance. An electronic actuator can adjust the permeability of airflow through an automated window opening and closing mechanism. The facade eliminates the need for traditional blinds and shutter system and revolutionizes building performance and aesthetics. The energy system of the prototype combines multiple renewable energy sources and conversion technologies. The 5 subcomponents are a photovoltaic solar system including PV panels and solar tubes, a solid thermal storage component, a liquid thermal storage component, a pellet cogeneration boiler for the production of thermal energy and electricity, and finally, a hydraulic system serving the distribution of energy and fluids on the components of technological apparatus and the indoor building environments. Thermal power is provided to the house by air in both cases of cooling and heating. The system does not include an electrical energy storage unit, so the produced electricity is consumed in the house or sent to the grid. The control system of the prototype, developed by MIT Model-Based Embedded and Robotic Systems Group, reduces energy consumption and enhances comfort. The artificial intelligence methods of building control were used in implementing an online risk-sensitive planner for the house called Peace Zulu. The controller fulfills 3 missions. First, it adapts the management of energy to activities of the residents by allowing the residents to input a detailed schedule and desired comfort ranges. Second, it optimizes operation of the HVAC system, dynamic windows, and thermal conservation capabilities of the envelope to limit consumption of electricity. And lastly, it provides a probabilistic guarantee that the residents' comfort constraints will be respected by acknowledging sources of uncertainty and planning accordingly. A wide spectrum of future projects and applications can be developed based on the already implemented systems of the prototype. Projects include the collection of post-monitoring data from prototype systems and performance evaluation, as well as security and deployment experiments of new sensory networks. Further development of systems learning capacity of the control could cater to occupant needs in increasingly more effective ways. Task optimization could be achieved by tracing use patterns, thus eliminating the necessity of user input. Real-time monitoring and statistical data of long-term use patterns could also provide a basis for prediction. As you can see, there's a large possibility of impactful projects that can be quickly realized from already implemented prototype systems.